Well, I've been under a great amount of pressure from David of the Creation Science to present an uplifting lecture for you. So I promise to keep things flowing, and I have a great amount of material to throw out at you. So I've been actively studying volcanoes in the world since I was a young boy, and the subject for me throughout my life has never gone extinct. Since my lecture of 2017, the vast magma chamber of information that has been gained by advances in geology and volcanology from recent eruptions, it has grown immensely. Since the present age of the internet and video drone footage, they actually fly drones over these volcanoes as they erupt, it has become quite a smoking hot topic these days. Volcanoes, let's think about this one, and if I had to pick a main thesis for this evening, this is it. Volcanoes themselves point to an almighty creator, and their actions, in many ways, demonstrate that we have a young planet. So just being a volcano and doing its thing, that's all it knows how to do, by their actions, they demonstrate that we have a young world, young Earth, not an old Earth. Volcanoes are windows into the interior furnace of the Earth. They are the only true global warming influences that will always dwarf any man-made global warming influences, no matter what scientists tell you. They are individually formed as unique creations of God that reflect in themselves a divine creator, because only a God could make something so awesome, so powerful, and yet so beautiful. Each volcano has behavioral traits, much like humans, that are specific to themselves. So you can't just lump them all together and call them volcanoes and they all act the same, do the same thing, because they don't. And that's what also makes them so hard to predict. Scientists debate whether massive volcanic eruptions can influence global climate change due to the mass amount of materials and pollutants that are thrown into the upper atmosphere. Some have said this would create global warming, because obviously it's coming from the furnace down below and it's throwing up all this hot stuff, so that's going to cause global warming. But history shows that actually it cools the Earth, because it blocks the sun's rays. Once it gets up into that atmosphere, it can stay up there for many days, months, even years, and so it actually cools the Earth. So using this theory of global cooling, which we will see proof in my lecture of, it helps to contradict this current global warming theory, as how can we have global warming and cooling at the same time? It doesn't quite add up. Historic volcanic activity will demonstrate that this warming and cooling of the climate is nothing new. All right, they advertise this global climate change as something new. It just has happened in the past, 100 years? When it's been occurring for centuries before man ever put his pollution footprint out there. That's what volcanoes do. They pollute the air, and they've been doing it for centuries. That being said, I'm going to show the first video. This is shot in over the island of Iceland. And you would think Iceland, well, that's too cold to have a volcano, right? Well, believe it or not, there's a volcano in Antarctica. So this one is unique because many people have the opportunity to have video footage of it, because it erupted in a non-violent form where people could actually go up and ride their bicycles or walk up to this fissure, this crack in the ground, and watch the lava without being in a lot of danger. So we'll watch this first video. Well, first off, how can you not see God in that? Right? Only God could be that miraculous to form things out of liquid rock. That's what's literally coming out of that volcano there. And that was not time-lapse photography. So those ridges and valleys were being formed instantly, like before your eyes. Right, so tonight, this is what we're going to go over. We're going to cover the types of volcanoes, because as I said, there's many types of volcanoes, so we'll kind of give you a 101 crash course on that. I won't get too technical on that, but types of eruptions and projectiles. Eruptions since 2017, you notice I updated that because my last talk was in 2017, and since 2017, there has been at least 100 or more eruptions. In 2021 alone, there was 80 eruptions out of 75 volcanoes, and 23 of those were new volcanoes. So volcanoes are not dead. We'll go over some well-known volcanoes and the eruptions, volcanic activity, and we'll tie it in with creationism and why I think the two are inseparable, that volcanoes actually show creation. I'll mention volcanoes in Scripture, because a lot of times people ask me, well, are volcanoes mentioned in the Bible? Well, we'll see about that. And then, of course, we'll summarize at the end. All right, so types of volcanoes. We've got the stratovolcanoes. They are called composite cone-type volcanoes. Examples would be Mount Pelée, Mount Vesuvius, Mount St. Helens, Mount Rainier, Mount Shasta, and I could list about another 300 or so. They are the typical cone-shaped volcanoes. They're usually a very solid, dense rock. Evolutionists would say that they have been built up over millions of years to get this high. Well, I have a problem with that. We'll talk a little bit about that. So that's the classic volcano. When you picture a volcano, if you had a 3-year-old draw a volcano, they'd probably draw a little cone. Right? That's the classic volcano. Then we've got the shield volcanoes, which good old Hawaii, thank you Mauna Loa for making my program just in time and erupting after almost 40 years. Hawaii is typically the shield volcanoes, and that's all Hawaii ever has. So they are very subject to the Hawaiian Islands. We have Mauna Loa, Mauna Kea, and Kilauea, to name a few. Shield volcanoes are very flat. They take up a lot of space because they don't gain in elevation as much as they spread out and can consume a lot of land area. This also makes the lava flow on a flatter plane. Usually when they erupt, you can outrun the lava because it flows rather slowly because it doesn't have all that gravity pulling down on it from the sides of the volcano. We have cinder cone volcanoes. Examples are Paracutin in Mexico. A lot of times cinder cones will form on the sides of composite volcanoes as like small auxiliary ones. Cinder cones are made out of cinders, so they're small rocks that pile up and pile up and pile up, and they make a cone, but it's not a solid cone. If you climbed it, it'd be very difficult to get to the summit because there's no solid surface. So it's just piled up cinder cone pieces. Those are really the only volcanoes that can ever be considered extinct. In other words, they won't do any more damage once they build their little cones. They usually cool off, and that's it. So if you're going to build a house by a volcano, choose a cinder cone. That's the best bet I can give you, because otherwise the other ones, no, all bets are off. Geologists and volcanologists have now decided that we're not going to call anything truly extinct because you just never know. But if you had to pick one, the cinder cones are definitely ones that could be considered extinct. Fissures. Fissures are oozing lava that sometimes can be explosive, like Laki in Iceland, or the one I just showed you, that's also in Iceland. It had a small cone, but it was mostly flowing out. They're not that dangerous. You can actually approach them rather closely. The lava just kind of oozes out of the ground because these fissures or cracks in the ground never really form high cones. They just kind of ooze lava, and then they cool off and go dormant for a while, and then they might come back to life. Then we have undersea volcanoes, which I was happy to see one go off. The Hunga volcano, it was an undersea volcano. These you never see above the surface of the water usually. They're exploding all the time under the ocean. And sometimes they come to the surface and then explode rather loudly, and those would be the undersea volcanoes. So those are your basic type of volcanoes, without getting too technical for you. Then we have types of eruptions, because of course, as I said, volcanoes don't erupt the same way. So we have effusive eruption with low silica and low water eruption. These are typically the Hawaiian eruption volcanoes. The lava seeps out or oozes out. It's a very runny lava. It flows, but it flows rather slowly. And because it covers large areas, it usually cools rather quickly as well. Probably the least dangerous to be around. The steam explosion volcanoes. Now you got a problem because we've got high water and low silica, typical of many stratovolcanoes. The early eruptions when pressure from rising magma is lava before it hits the surface. So it's the same stuff, we just call it lava once it hits the surface. The magma hits the water table and blows out the old deposits in the crater vent. So usually when composite volcanoes wake up from their 40-year nap, they will do one of these blows because they've been so plugged with debris. The water hits and it's got to go somewhere. It usually finds the crater and you get a minor explosion. The submarine eruption, these are the undersea volcanoes. They erupt just under the surface of the water, and it's when the seawater hits the magma, produces clouds of steam and ash. The island of Surtsey was formed like that, and the Hawaiian Islands were formed like that. The Strombolian type eruption, now we're getting a little heavier. This one, the magma becomes viscous and the trapped gases escape spasmodically, causing glowing lava bombs. And yes, they are bombs. You don't want to be anywhere near a lava bomb, as they will hurt you. They can be as big as a car or a house, so you don't want to be anywhere near a lava bomb. Ash and smoke regularly, but not often deadly or dangerous. Mount Stromboli, Mount Volcano, and Mount Etna are examples of these. Now, Stromboli and Etna are constantly erupting. They're very active, and they're doing these minor Strombolian type of eruptions. They're pretty. They make great video, but they don't do a lot of damage. Now we're getting into the dangerous ones. Plinian explosions, these are extremely gas-rich, viscous magma that explodes deep inside the volcano. The vent creates a gun barrel that shoots the material straight up, twice the speed of sound. That's a lot of pressure. Vertical columns as high as 20 miles or more. We've had vertical columns up to 46, 50 miles high. That's high. Mount Vesuvius in 79 AD. Okay, we probably all heard of that one, right? And that's where the Plinian name came from Pliny the Elder, who perished in the eruption. He just had to get a little bit closer because he was one of the first volcanologists before we even knew what those were. He was just a Roman guy who started studying volcanoes, didn't know a lot about them, ventured a little too close, and he perished. Then we have, well, I want to say my favorite because I sound like I'm not into disasters and terrible things, but my favorite type of eruption is called a glowing avalanche, or the French would say the Nuit Ardente, or the Pelian eruption. Viscous gas-rich magma erupts under fairly low pressure. A dense, incandescent cloud of superheated ash and pumice suspended in trapped air, and their own escaping gases falls back to the earth and rolls downhill in a fiery avalanche at up to 100 miles an hour or more. Mount Vesuvius did this, Mount Pelée did this, and Mount St. Helens did this. Not much survival rate with these. You could ask the people of Pompeii, but yeah, none of them made it, so they couldn't tell you much about what happened. It happens that quickly, this superheated gas. So very dangerous. I love this volcano explosivity index. So yes, we actually rate our volcanoes according to the levels on how they erupt. We go from number 1 being gentle to 8 mega colossal. Well, that's pretty logical, isn't it? I just love the first one, gentle. I don't know who came up with that one, I didn't. But there's nothing about a volcano that I would consider gentle. Okay, you don't want to pet one. You don't want to take it home as a pet. Okay? So a gentle eruption, I mean, they list Hawaiian volcanoes, but if you live on Hawaii right now, Mauna Loa, I don't think they'd consider that a gentle eruption. But so gentle is kind of a interesting term there. It's not like, pet volcano that kind of occasionally burps up some lava and, oh, it's okay, he's all right, he'll be fine. Then we go to explosive, Mount Stromboli, Mount Unzen, Galeras, volcano. Then we have number 3, severe, Lassen Peak, Soufriere Hills. Cataclysmic, starting to get worse, Mount Mayan, Mount Pelée. And then it just goes up from there. Paroxysmal, Vesuvius, Fuji, Mount St. Helens, Colossal, Krakatoa, Nova Rupta, Pinatubo, Super Colossal, Mount Mazama, Mount Thera, Taupo, and Tambora. And then we have Mega Colossal, Yellowstone, Tobo, and Taupo. Level 8, no human has ever seen. So we really don't even know how big they can be. Evolutionists guess at how bad they were based on the millions and millions of years of piling up of stuff around the area, and then they say, wow, this must have been mega colossal because look at all this stuff that came out. Well, we don't know because no one has ever witnessed a mega colossal eruption. So, but the evidence is there that something rather large happened because of the aftermath of those volcanoes. So now we get into the types of projectiles. So this is what volcanoes put out. The finest particles are considered dust. They are finest and smallest particles ejected. They can travel into the upper levels of atmosphere, stratosphere, and block sunlight and affect climate and sunset colors. I have 2 examples back there when you get a chance of Mount St. Helens dust. And the stuff is like a fine talcum powder. It's actually very soft to touch, but you wouldn't want to breathe it in. This is the stuff that if you get it in your lungs, if you looked at it under a microscope, it's like little pieces of glass. It will serrate your lung tissue. That's not good. So when people are suffocated to death by the dust from volcanic eruptions, they can't breathe because that dust is ingested into their lung system. Very hard to block out even with the strongest face filters because that stuff is going to get everywhere. Then you have the ash, which a lot of people think the dust is the ash, but ash is actually a little bit bigger particles, like a very fine gravel mixture. I have another example of that from Mount Pinatubo back there in the Philippines. You can see the heavier particles, the ash. Doesn't fly as far, doesn't get up as high in the atmosphere. Lapilli, the bite-sized fragments of frothy lava. Pumice, larger rock fragments filled with gas and air bubbles, some of which can float in water. You see those in landscaping. People like to put those around their landscape, the little brown things with the little bubble holes in them. That's pumice. We also used to brush our teeth with that, and that would remove your enamel and make them very white. Lava bombs. These are bigger chunks of rock, hardened lava that can be as small as tennis balls or as large as houses. You just never know what's going to come out. Depending on how they're formed in the eruption, that's going to give you that size. Then you have A'a, which is one of 2 main lava products specifically to Hawaiian volcanoes. So when I said earlier, certain things come out of certain volcanoes, Hawaiian volcanoes put out that that no other volcanoes do. It's a flowing lava with sharp chunks of lava in it, scoria. Then we have Pahoho, which is another Hawaiian-specific. Pahoho, smooth flowing lava, forms tubes when cooled. Kind of unique. And then, of course, we have the Noi Ardon, which is the extremely heated gas cloud and not real common with eruptions. There were two really great volcanologists that have passed on, and they were fervent about recording some of these avalanche cloud eruptions, and they were fairly rare in occurrence, and they would travel the world. And we learned a lot. A lot of our video footage on videos of volcanoes were from this couple. And they went to Japan. Mount Unzen was erupting, and they were on video, and you can see it on YouTube. And it's actually kind of a scary video because the husband, he actually kind of talks about his death. That day he'd be dead. They were talking about the Noi Ardon, and they said, nah, we probably won't see any real big ones because it hasn't been doing that. And literally that next day he said, well, if I have to go, meaning he stuck his head in near enough craters that he could have been killed, they wanted to get that good footage of a glowing avalanche, and that day they went up to the mountain and a big one let loose and they were incinerated. So, died what they love doing most. Happens to a lot of volcanologists. So, they're very dangerous. Then we have one of my favorite volcanoes, and yes, I have actually favorite volcanoes, ones that I study the most, ones that I'm fascinated about the most, because there are certain ones that behave so uniquely and so ferociously that you can't hardly not notice these. Krakatoa, or the natives pronounce it Krakato, erupted in 1883. It was the loudest noise ever recorded by man in history. This blast column was said to have shot up to 24 miles in the air. Captain wrote about his experience. He said, the day of judgment has come. It was that violent. Official number that was killed was 36,417 people. 11 cubic miles of rock and ash shot into the atmosphere. That's a lot of material. The amount of material ejected would cover the entire island of Manhattan up to 200 feet deep. So it's a lot of stuff coming out of that one. 165 villages and towns were destroyed, and the world found out about Krakatoa within hours afterwards, thanks to the telegraph and the newspaper reporters. So it was one of the first major eruptions that you heard about all the way around the world simply because the telegraph had been invented and newspaper reporters covered it. It affected global weather. Bright red sunsets were observed around the world. It cooled the Earth's temperature by 0.5 degree. So there's your global cooling. And artists painted these many years, for 3 years afterwards, they were painting these interesting pictures, and now we understand that they're from that ash that was up in the, or dust that was up in the atmosphere. When Krakatoa exploded, it basically blew itself apart, and that's what a lot of these volcanoes will do. Krakatoa is one of them that has a history of blowing itself apart and then rebuilding, and then blowing itself apart and then rebuilding. It formed a caldera, which is it collapses and forms, usually in the water, it'll form like a big pool of water. And when it blew itself apart, it was actually 3 different cones that blew at the same time. And then, of course, it was just water, and then for many years, nothing was there, just remnants of part of this big island. Then in 1927, all of a sudden, a fisherman noticed the water was bubbling in that area, and within days, a little cone started popping above the surface of the ocean. And it would grow, and then the water would erode it, and it would go back down below the surface of the water, and then it would rise again, and then the seawater would erode it some more. And finally, it was an island. So finally, it built up enough material, and it was an island. And it formed right in that area where the craters had been. So it's growing rapidly and almost the same height as the earlier mountain of Krakatoa. Interestingly enough, that's going to happen until the end of the world, because that's how Krakatoa operates. So as I said, that's the footprint of that volcano is always going to be that way. It will build up and blow itself apart and build up and blow itself apart, and it will continue to do that. Nothing man can do to control it. It's just going to happen that way. So this next video we'll watch is what the natives call Anak Krakatoa, and that is the son of Krakatoa. So they've named the baby that was formed in 1927. It's no longer a baby. It was up to about 1,000 feet high. And in 2018, it had been active up to that point. But in 2018, something happened to baby or son of Krakatoa. It started as early as 2014. It was starting to erupt a little bit. And thanks to modern technology and video, now we actually can see it, whereas in 1883 we couldn't see the big Krakatoa blow apart. But you will see this little island that once was just barely above the surface of the water in 1927. Not a million years later, it's over 1,000 feet tall. And then you'll see what happens to Anak Krakatoa when it decides to blow. To fill in what didn't show was the cone of 1,000 feet high was gone, and it was a depression in the water just like the previous Krakatoa. So like father, like son, works for volcanoes too. Little Krakatoa was not much less than the bigger one. And it formed a caldera like the previous one. Within days, it was already building a new lava dome. Not within millions of years, within days, another lava dome is forming, which means baby Krakatoa is having a baby. So after blowing itself apart, 1,000 feet of peak is gone. Oh, it's not done. It's going to form another dome. And the dome forms and erupts and forms and builds, and it'll be 1,000 feet, and it'll blow itself apart again. So it's just that circle of life for volcanoes. So would you want to live on the island of Java, even though they have great coffee there, or Sumatra? No, absolutely not, because those natives that do live there usually lose their lives or their houses, because when Krakatoa does erupt like that, because of the situation where it's located between the islands, it's a shallow area of water. When it blows like that and collapses, it forms very nasty tsunamis. And they have nowhere to go with the water, so it goes to the one island and to the other island. It's kind of secluded in there, and it will destroy property. And it's been doing that. It did it in 1883, and the local people didn't learn their lesson, or they continued to build there. And recently, Krakatoa, when it did erupt like that, it killed a couple hundred people. And there was YouTube video of it. A band was playing on stage. They had no idea it was at night. A tsunami came and wiped them off the stage. A couple hundred people were killed. So it's what they do if you're not listening to their warning signs. This next one made news in 2021. 2021 was a very hot year for volcanoes. This one hit the news. My sister actually informed me of this one. I usually stay on top of these things, but there's so many popping off that even a guy like me, I can't always monitor them all. So this one formed on an island off the Canary Islands, not an area that you had heard of. I mean, it's not like Hawaii where we expect volcanoes or Krakatoa. No, it's an area that never expected that. Started September 19th, 2021, first volcanic eruption on that island since 1971, so this wasn't real common. 85 days, it's the longest known eruption, so it lasted 85 days. That's a long time to have an eruption last. Caused 7,000 people to evacuate. The lava flow was 3.5 kilometers by 6.2 kilometers. Reached the sea, destroying over 3,000 buildings. Cut a coastal highway and formed a new peninsula. And destroyed one whole town. So watch a little this one here. So now you notice a lot of lava with this one. This one's doesn't have the pyroclastic flows. This one's got the lava. All right, then we got another one that decided to make its presence known. Because see, sometimes these volcanoes are a little sensitive and they like to be noticed. That's the way I figure it. They get neglected, people forget about them, and then once in a while they like to come to life and say, hey, I'm over here, you know, and volcanoes have a nice way of doing that. They wake up from their long naps and they announce their presence like we could forget they're there, but people do. Mount Cinnabung was another eruption that happened in 2021. It started in 2017, increased activity with a large ash eruption in December of 2017, continued in 2018, killed 7 people. So you notice the death tolls are going down, fortunately, with modern technology. We can pay a little more attention and we're not seeing the staggering 36,000 people killed anymore. Another eruption, 2018, no fatalities, but 1.6 million cubic meters of material was blown from the summit. And then July 28, 2021, sent a massive column of smoke and ash, 4,500 meters. So that's one of those tall ash columns, and then when they collapse, that's when you get the glowing avalanche. They don't always collapse. That's why it's kind of rare when that happens. Then we got this one, Hunga Tonga. No one ever heard of that one. An underwater volcano. You didn't hear about it because you didn't see it. It wasn't above the surface of the water. There was a little bit of a depression in between two pieces of islands from a previous eruption. And then one day in 2021, this one comes to life. This one ended up being the largest amount of ash and dust put into the atmosphere of all recorded history. This is the one that kicked off tsunamis that they actually gave the alert out to California. That's a long way away from this in the South Pacific. The blast was also heard as far away as Alaska and Kentucky. So the sound from these volcanoes can be very great. Then we have Le Soufrier. That one started in 2020. It had been dormant since 1979. This one's important because this one actually had to do with a previous eruption. This is a very deadly mountain as well. April 9th, 2021, there was an explosive eruption causing pyroclastic flows. So here we had the pyroclastic flows, the deadly flows. The explosivity index was a 4. 16,000 people were evacuated. Volcano had killed over 1,000 people in 1902. So this one has it's a deadly eruption. Incidentally, the people, when this one erupted, this was during the COVID thing. So to evacuate the people off the island, they wouldn't take them off the island if they weren't vaccinated. So I guess you're left to, fight the pyroclastic flows. That's a better option than the COVID thing. I found that interesting. So the cruise ships would refuse to take the people if they weren't vaccinated. So you just stay on the island with the volcano, you'll be okay. So that was kind of disturbing. And they have that, the history of it, because this is one of the volcanoes I study with my favorite, which is Mount Pelée. Same thing happened in Mount Pelée in 1902. The government said, well, you guys have to vote. The villagers of 36,000 people had to stay in St. Pierre because the voting was coming up and they had to pick a new governor. And Mount Pelée is not dangerous. In fact, the dust is good or the sulfur fumes are good for the congestion, is what they told the people. And they refused to let the people off the island because it wasn't going to get that bad. And then 30,000 of them are vaporized by a Noyardon. And then just 2 islands away, in present time, they do kind of the same thing. You can't get off the island because you're not vaccinated, but you stay with the volcano. So, interesting. And then, of course, we have Kilauea, which Kilauea has been going. That's the real active one on Hawaii, right next to Mauna Loa, which just woke up recently, a couple days ago. Kilauea has been going almost every day. It's a side cone, a separate chamber than Mauna Loa. So it's an independent volcano, but right near the other one. But that one also blew quite violently in 2021 as well. Now, here we have volcanoes and creation. So the Bible mentions volcanoes. Well, yes, sort of does. Not specifically, but enough to make mention. Psalm 97:5, the hills melted like wax at the presence of the Lord of the whole earth. Psalm 104:32, he looks on the earth and it trembles. He touches the hills and they smoke. Psalm 144:5, bow your heavens, O Lord. Come down, touch the mountains, and they shall smoke. And we got a couple other ones up there, too, that you can read. Mountains quake at him, and the hills melt. Mountains shall be molten under him, and the valleys shall be cleft, the wax before the fire. I think that's plain enough. It's not real specific, but... Now, volcanic activity and creationism, so are the tie-in. Well, creation. God could have utilized these powers, these powerful molten rock furnaces to create the world, and of course he probably did. We don't know, we weren't there, we didn't witness it, but we witnessed volcanoes, and they form islands and peninsulas out of nothing that was there before. The Hawaiian Islands are examples of a hotspot that's constantly forming, so new island material. So some of these inactive volcanoes could have been used in creation. Another example, island of Surtsey, formed near Iceland in 1963. First you have boiling seawater, next thing you know, volcano breaks the surface, and by 1967, you have an island that wasn't there before. Even staunch evolutionists are starting to realize that through great catastrophes, land formations like the Grand Canyon can occur rapidly. Oh, wait, you mean it didn't take millions of years for the Colorado River to cut the canyon? They're realizing that maybe that could have happened rather quickly. Volcanoes like Mount St. Helens built a lava dome. That's what they do. They build these lava domes. Krakatoa is building a lava dome. And they're hundreds of feet high in several short years, not millions of years. So it's happening right before our eyes. These same scientists are arguing that the world is 50 million, or wait, maybe 60 million, 70 billion, I don't know, something. Wherever they pull it out of whatever pocket, they get those terms. And yet they can witness Mount St. Helens building a lava dome in a matter of days, months, years that towers. If the world was millions of years old, how high would that lava dome be? Because volcanoes are doing what they do. So if they've been doing what they do for millions of years, well, then these volcanoes should be 50, 60,000 feet high, right? Theoretically, the math just doesn't add up because they constantly are building and doing their thing. Well, if this world has been around for millions of years, how come we don't have mountains that are 60, 70,000 feet high? Because volcanoes don't stop doing what they do. Mountains like Tambora and Krakatoa can blast themselves apart in seconds. So why does that same awesome power created by God have to take millions of years of lava flows to build up the mountain? Well, it doesn't. It doesn't. You see these lava flows coming down the sides of the mountain and cooling in a matter of days, months, and you have a ridge that wasn't there before, and the ridge is several hundred feet high. Wait, but it has to take millions of years to put that ridge up there. No, it doesn't. Volcanoes teach us that we're not in control. That is a fact. God is in control, right? We can't make them erupt, and we can't stop them from erupting. Mount St. Helens erupted with the power equivalent to 440 million tons of TNT, and that was a small one. And we play around with splitting the atom and calling it an atom bomb, and oh, wow, that was powerful. Whoa, and it was, but Mount St. Helens, and then you have Tambora or Krakatoa with way more power. God gives us warnings to heed, and those that are wise listen, right? The house on the rock, the wise man, right? If we listen to the warnings, volcanoes give us warning of impending eruptions. Those that are wise listen and are spared. The foolish man, house on the sand, right? Okay, we have positive and negative effects of volcanoes, right? Positives, they give us fertile soil. The soil around volcanoes is so fertile, it grows the best tomatoes in Italy, right? There's a reason for that, the volcanoes. So we need them, or you wouldn't have those tasty tomatoes to have in your garden, right? They serve their part in circulation of the water supply for the planet. Well, that's kind of important. We kind of all need water, don't we? They help with the releasing heat and cooling the Earth's temperature. Oh, you mean man doesn't do that? Wait, no, we're in control, right? You know, our pollution and emissions and everything, that's going to control the world. No. How about the volcanoes do that? They're a source for geothermal heat. And they make islands and add to continents, right? Negatives. Well, yeah, there's always negatives, right? They destroy property, towns and cities, and the landscape. Well, the landscape, you know, I'm okay with, but towns and cities, if you put them right near a volcano that has a history of erupting, well, that's kind of on you, right? So that's preventable damage, but it does happen. They kill people and animals that do not heed the warnings. They pollute the air with toxins that can affect environment much greater than man-made emissions and pollutions. Supervolcanoes, we've got a few of them. There's about 7 in the world. Yellowstone Park is above a supervolcano, which has a history of the mega, 7 or 8, which we haven't ever seen. Taupo, Caldera, Lake Toba, several others there in Europe. They have past footprints of huge eruptions and could possibly play a future role in the destruction of the world at Christ's second coming if he chooses to do so, right? He said he wouldn't destroy the world with a flood again, but he didn't say anything about volcanoes. Perhaps some of these might be used in Judgment Day. You never know, right? That's up to God. Here's an example of what happened after a Noy-Ardam. Okay, there's the village of St. Pierre. Mount Pelée erupted. It was a beautiful city. It was the Paris of the West. Right? Saint-Pierre. There's Saint-Pierre on that fateful May day when most of the people were in church worshiping, praying that God would deliver them, and he incinerated them in the church. Well, he allowed it to happen. And so, yeah, massive destruction. And would you believe it? People were foolish enough to rebuild Saint-Pierre. And Saint-Pierre is a little village. It's about half the size it used to be. But people are still living there. Not me. I wouldn't want to live there. Because I know what that mountain can do. Here's an example of the Tower of Pele. Pele was the mountain that took out Saint-Pierre there. A hardened lava plug. Now these form in the crater after the eruptions. It was pushed out of the crater. That's the plug that sometimes blocks the throat of the mountain, causing the pressure like a cork in a bottle, and then it's got to go somewhere and it blows. Well, that plug stood as a monument to the 30,000 that were killed that day. They looked up and they saw this mountain, this rock sticking out of there. It stood 1,000 feet high and 500 feet wide and was formed within the crater in a matter of days, not millions of years. Right? Volcanoes do their things, and they don't take millions of years to do it. So in summary, greatest thing we can learn from the study of volcanoes and their history is that we are not in control, God is. He made them. We don't make volcanoes. Well, I did in science class. It was a real little one. God created volcanoes, and they truly speak to us with evidence of a creator and a young earth if we choose to listen to them and look at the evidence using God as the center of it all. Volcanoes have a unique and individual past history, just like we do. They have specific characteristics similar to how we humans were created. Every one performs in its own created manner and purpose. So yes, God uses volcanoes. Yes, they can cause bad things to happen, but we also need them for our life, for things in this world. As we continue to study volcanoes in the future, we can truly see that the divine creator can use them for creation and also for destruction. It's not all about the power of science, but all about the power of God. I have one final video here of this Icelandic one. This one is a different area in Iceland. It's the fissure, so it's just a crack in the earth, and it's forming just lava fountains. Not doing any destruction, just leaking out of the earth. People are coming to watch.
Okay, I just made it to the volcano. It's been here for a few minutes and my mind is just completely blown. It's crazy how quickly this eruption has started and how big it is now. Yeah, I just cannot believe it. And the last thing that I would imagine this morning when I woke up would be to be standing and looking at this. It's just crazy. I thought the eruption was gonna happen maybe like in a few weeks, and now it's here and it is so beautiful.
I'm a PhD student with the University of Iceland, and I just went to the lava flow and took a piece of lava out of the flow, and later we're going to analyze that in a lab to understand the chemical composition of the lava, because it can tell us something about the gas composition and the different metal components that are sampled by this lava.
So this is absolutely incredible to see. We were here actually last year when the eruption happened, just only like within 24 hours later. But this eruption is at least 5 to 10 times bigger. And I have to say, it's like this dancing fire is so different from the other eruption that I'm mesmerized by this. It's beautiful.
And yes, they actually have volcano chasers, but they have it a lot easier than tornado chasers because they don't have to go as far, because volcanoes don't move around so much. This is the bibliography for further reading for those of you who want to learn more about volcanoes. I recommend these are some of the top picks from my library. And with that, we'll close and I guess take any questions you might have.